Exercise, we're going to demonstrate how we can construct a couple regular polygons by a couple different methods according to what information is given. Okay, first we're going to construct a regular pentagon. Of course, that's a five-sided figure of perimeter 30. Next, we want to construct a regular dodecagon of radius 10 centimeters. And lastly, we want to construct an equilateral triangle of apothem 5. Equilateral triangle with apothem 5. Okay, so let's see how we proceed with that. Okay, constructing a regular pentagon with perimeter 30 means, okay, each side, of course, would be 6 units. Now, drawing a segment and measuring that segment and trying to get that to be exactly 6 units can at times be a challenge. Okay, so I'm going to show you, demonstrate for you, that sometimes getting that exactly to 6, there it is, it's not going exactly to 6. So that's not the best way of constructing a segment. So we're going to show you another method that will work all the time. Okay, so here's a point A. All right, what I'm going to do is I'm going to translate that point, okay, by the prescribed length of 6 units. Okay, so I'll select that point. I will translate 6 units, okay, at any angle, makes no difference. 90 will be straight up, okay, 180 if you want will be straight to the left. If you want to go negative 180, doesn't really matter. Okay, all right, so we'll translate it. All right, there it is. Okay, now the length is 6 and it will always be 6. If I don't like it there, let's move it over. Okay, so here's my length of 6. Okay, now all sides will be exactly 6 units. How will we proceed with that? Well, okay, we're going to do the rotation. The angle measure for the regular the pentagon, hopefully you remember, is 108 degrees. So I'm going to rotate about this point, the segment and the point A. I'm going to rotate, okay, 108 degrees. 108. Okay, rotate. And I'm just going to keep that rotation going. There's my center of rotation now. Rotate again. Transform. Rotate 108 degrees. Okay. Select that point. Transform. Rotate 108 degrees. Okay. And lastly, either you can translate or you could, okay, just draw the segment now, and we can confirm that when we fill this segment in and find its perimeter, construct the quadrilateral interior, or the pentagon interior, okay, we will find, okay, the area, if we want to measure the perimeter, is exactly 30 units, okay? Exercise 2. Construct a regular dodecagon of radius 10 centimeters, okay? Again, the exact length going to be found the same way, okay? Select the point, translate 10 units, okay? Translate that 10 units. So I'm going to transform, translate by a fixed amount of exactly 10 units. I've translated that. I think, where did it end up going? Let's see. And here it is up here. So that's my translating in 10 units. Okay, I'm going to have to move that down a little bit. That's my radius. So I can draw my segment here. Now, the radius of the dodecagon, okay? For the radius, we need a central angle. Since the dodecagon has, okay, 12 sides, the central angle will be 12 into 360, or 30 degrees. So I'm going to rotate this segment, through 12 rotations 30 degrees each. So call that the center, select the segment, select the endpoint, rotate, okay, through 30 degrees, through 30 degrees. Rotate again through 30 degrees, okay? Again, till you come all the way around. Rotate, transform, rotate, okay, through 30 degrees. And so on and so forth. I'm not going to go through the whole thing. You got the idea. When that's complete, you will have a regular dodecagon. And of course, we can then simply construct the segments which will actually form the dodecagon and be done with it. Okay, so I have to complete that rotation completely around until I've generated my dodecagon. Last construction is to construct an equilateral triangle with an apothem of 5. An equilateral triangle with an apothem of 5. Again, what do we mean by the apothem? Okay, well, the apothem is the radius of the inscribed circle. That's what we mean by apothem. Well, let's get first off a segment of exactly 5 units. Okay, so again, best way of exactly 5 units, okay, is again through a translation. So I'm going to translate 5 units and in 180 degree direction. Makes no difference. Okay. All right. So translate 5 units at 180 degrees. Okay. So that segment is the apothem. Now, what is the apothem? Okay. The apothem is again the radius of the inscribed circle. So let me construct a circle with this point as my center, and that is my radius right there. Okay. Now, at this point, I have to put a triangle, an equilateral triangle around this. An equilateral triangle around this. So, okay. Now remember, the equilateral triangle is going to go around this, and remember that the apothem meets the segment of the triangle at its midpoint. The best way to approach this is as follows. Okay, I'm going to select and draw a tangent, because if there's a triangle that is being inscribed by the circle, it means the sides of the triangle are tangent to this inscribed circle. Okay, so let's proceed with that. All right, I'm going to select this, select that point, and construct, okay, the perpendicular line. All right, now, okay, from there I want to have 3 equally spaced segments or around the circle. So what I will do is do exactly that. I will rotate about the center point here. So let me double click on that center point so that it's identified as the point of rotation, and I will select this and the line, and I will rotate 3 equal divisions will mean I would have to rotate it 120 degrees. Okay, there I go, rotate, and I will do that rotation once again. Okay, transform, rotate, 120 degrees, rotate it. Okay, and there I will mark my intersections of these segments, of these lines rather. Construct the intersections. Okay, I think I got too many things selected, so let me come here again, select, select, construct, intersection. All right, select these, construct the intersection, and come down and get my other intersection down here, okay, which I'm going to have to construct this way, okay. And again, I get too many things selected. Select, select, construct intersection, and the intersection is there, and you can see it is now able to have my equal arrow triangle is now going to be able to be constructed. Okay, I will have to pull this up and construct my segment here, and then construct my segment from here on down. Okay, and there's my equilateral triangle of apothem, okay, equaling 5. Okay, so that's how we can construct some of these regular polygons in accordance with the description. Okay, there you have it.